In this video, we will be discussing molar mass and how we can use this in chemistry. Here are our objective and essential question for today. So your objective will be able to describe and determine the molar masses of elements and compounds. And your essential question is, what is molar mass? How do we calculate it? Again, I encourage you all to pause the video at any point that you need to get extra time to write these down whenever you see this handwriting icon on the screen. So let's talk about our molar mass. Now, the molar mass is the mass in grams of 1 mole of a substance, and it is measured in units of grams per mole. So as a review, if you watched my video on moles and Avogadro's number, just like 1 dozen is always going to be equal to 12 units of whatever you have a dozen of, and a pair is always going to be equal to 2. A 1 mole is always going to be equal to 6.022 times 10 to the 23rd units of that thing. Now, because 1 mole is equal to 6.022 times 10 to the 23rd of that thing, and we have different atoms of different sizes on the periodic table, 1 mole is going to have a different mass for an element, or for a specific element, than it will for a different element. So if, say we had 1 mole of hydrogen, which is one of the smallest atoms on the periodic table. So hydrogen's about like this, let's say. And we were comparing that to 1 mole of oxygen. Now, oxygen's a little bit bigger than hydrogen. So if we were to measure the mass of 1 mole of hydrogen, we're going to multiply this hydrogen atom by 6.022 times 10 to the 23rd. And we would get that if we were to put a bag of a mole of hydrogen, so this is a mole of hydrogen, I'm going to write 1 mole H on the scale, we would see that that scale read 1.008 grams per mole, which is telling us that 1 mole of hydrogen weighs 1.008 grams on the scale. And we know that in that bag, there are 6.022 times 10 to the 23rd atoms of hydrogen. If we did the same for oxygen, so say we had this atom of oxygen, we would still be multiplying it by 6.022 times 10 to the 23rd. And say we put that all in a bag and placed it on a scale, just like we did for hydrogen. So this is 1 mole of oxygen. Put that on a scale, took its mass, and you would see that 1 mole of oxygen is going to have a larger mass than 1 mole of hydrogen. So that's about 15.999 grams per 1 mole of oxygen. So again, you can see that this is going to have a bigger mass than this. And that is all due, it all is rooted back in the size of those atoms. So hydrogen is a smaller atom than oxygen. So if we have the same number of oxygen atoms and compare it to the number of hydrogen atoms, these are just going to be, it's going to be a smaller mass than oxygen. Now, if we wanted to find the molar mass of any element on the periodic table, we would simply look to this number. So this small number on the bottom of any box on the periodic table of an element is its molar mass. Now you might be thinking that's kind of odd because that I learned that this was also the atomic mass. Well, I can tell you that it is actually both. So this number on the bottom is the atomic mass of that element measured in AMU, or atomic mass units, which describes how big that atom is. And it is also the molar mass measured in grams per mole, which again is another kind of way of describing how big that element is, or one atom of that element is. But this time we are measuring a mole of those atoms of that element. So what this number is telling us for carbon here is that 1 mole of carbon on a scale weighs 12.011 grams. So say we were trying to find the molar mass of this compound. Now we know how to find the molar mass of a one element, but we don't actually know how to find the molar mass of a compound yet. Now all we're going to do is count the number of atoms of each element we have in the compound and then multiply it by that element's molar mass. So in this compound, this is C6H14, that's molecular formula. So that is telling us that we have 12 carbons and we have 6 carbons and we have 14 hydrogens. So if I want to find the total molar mass of the compound, well, I need to look at the molar mass of carbon and multiply it by 6 because we have 6 carbons in the compound. So 6 times 12.011 grams per mole is equal to 72.066 grams per mole, and 14 times hydrogen's molar mass, which is 1.008 grams per mole. $14.112 grams per mole. Now we're not done yet. So we found the total molar mass of all the carbons in that compound here. We've found the total molar mass of all the hydrogens in this compound. We need to add them together. So our total molar mass for this compound is actually going to be 72.066 plus 14.112. And you should get a value of 86.178 grams per mole. I'm actually going to box that in red. So that is our total mass for this compound here, C6H14. So again, to sum it up, all you are doing is multiplying the molar mass of each element by the number of atoms of each element that you see in the compounds, and then add those together and you get the total molar mass of the compound. I hope this helps, and I look forward to discussing this more with you all in class next.